And today I will be talking to you about equivalent resistance in series and parallel circuits. So first, let's talk about series circuits. Series circuits are circuits in which all the resistors share the same current. So, for example, if I have two light bulbs screwed here and they're both shining brightly, if I was to add a third light bulb, these two light bulbs would dim and be equal to the same light that the third light bulb is sharing with them. On the other hand, if I were to have two light bulbs and I take one of them out, then the current through the resistors will be interrupted, which means that the light on the other light bulb wouldn't shine. Okay, so the formula for equivalent resistance in a series circuit is Req series equals R1 plus R2 plus R3, and so on and so forth, depending on how many resistors you have in the circuit. And the unit for equivalent resistance is ohms. Next, I will talk about resistors in parallel. So in a parallel circuit, the current is split at this point. So the current goes this way and it goes this way. So unlike the series circuit that we talked about, if we had two light bulbs screwed in at this position, if I were to take one out, this one would stay on because this is not sharing the same current with the other resistor. And the formula for equivalent resistance in parallel is 1 over the equivalent resistance in parallel equals 1 over R1 plus 1 over R2 plus 1 over R3, and so on and so forth, depending on how many resistors that you have. Or, if it's easier for you, you can write it as equivalent resistance in parallel is equal to 1 over R1 plus 1 over R2 plus 1 over R3, and then find the inverse of that number. So now, let's go over practice problems for resistors in series. So here's our circuit. We have a 5 ohm resistor, a 10 ohm resistor, and a 15 ohm resistor. So if we were to use our equation that we came up earlier for series circuits, we have Req series is equal to R1 plus R2 plus R3, and that would be equal to 5 ohms plus 10 ohms plus 15 ohms, and our answer will be 30 ohms. Next, we'll go over practice problems for parallel circuits. So, in this circuit, as you can see, the current diverges at this point, which we have a 10 ohm resistor on one side and a 5 ohm resistor on one side. So what we will do is we will use the equivalent resistance equation for parallel circuits, which is 1 over R1 plus 1 over R2, and the inverse of that number. So we get 1 over 10 ohms plus 1 over 5 ohms, and the inverse of that will be equal to 3.33 ohms. So now what happens if we have both resistors in series and parallels in the same circuit? What we would do is, the easiest thing for me to do is always do the ones in parallel first. So what I did was I did Req for P for parallel is equal to 1 over 5 ohms plus 1 over 5 ohms, and the inverse of that number, which gave me 2.5. At this point, this resistor, these two resistors, and this resistor are in series. So all I did was Req in series is equal to 10 ohms plus 2.5 ohms, which we found for parallel for this portion of the circuit, plus 10 ohms is equal to 22.5 ohms. So I hope that was helpful for you all. If it was, please like this video. Happy physics!